Hi, I'm Professor Goins, and welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in pretty much any college mathematics course, please consider subscribing and then checking out our playlists and watching our videos and then liking those videos and sharing them and commenting and all those types of things. They're all greatly appreciated and help our channel to grow, so please consider doing all of those things. Let's get into the current video. Graph of a vector function. Let's take a look at, well, first and foremost, let's go back to the basic concept of what a graph is from your, say, Calc 1 days or pre-calc days. If I give you the function f of x is equal to, let's say, x plus 2. Okay. Well, remember that one way I can look at this is I make a table of values, say x value, y value. If I plug in, let's say 0, the y value is 2, or the function value is 2. If I plug in 1, the y value is 3. If I plug in 2, the y value is 4, so on and so forth. And therefore, we get the following graph. If I go 0, plot the point 2. If I go over 1, I'm going to plot the point 3. If I go over 2, I'm going to plot the point 4. And of course, this is a line with y-intercept 2, slope 1. But the idea is that I plot all of the outputs and I come up with some sort of a pattern and I get the graph of the function. In other words, I'm plotting two pieces of information, the input and the output. The input of 0, output of 2. Input of 1, output of 3. Okay, so this, say in particular, this point right here is over 1 up 3. So my input comma my output. So remember that when we start talking about graphs of vector functions. Well, what does a vector function look like? Let's take a look at a very simple example similar to what I just did here. Let's say I give you the vector function r of t is equal to, well, how about t comma t plus 2? First and foremost, what are the inputs and the outputs? So for this function here, let's look at the input, the corresponding output. Well, inputs, right, this is a function from R1. So this is a function R takes real numbers and outputs vectors. So it's a function from R to R2, whereas up here, this was a function from the real numbers to the real numbers. One input, one output. Down here, I have one input. I do have one output, but it's that one output is a vector. Let's say I was to plug in the value 0. What's the output? The output is the vector 0, 2. Again, as a vector. If I input the value 1, right, so my t value, my input, it's just a single real number. The output is the vector with components 1 and 3. Plug in 2. What are the outputs? Or what is the output? The output will be the vector with components 2 and 4. Now, you could say, you know, looking back at that previous example, well, I'm going to somehow plot my inputs and my outputs. For the input 0, I'm going to plot the vector 0, 2. For the input 1, I'm going to plot the vector 1, 3. But we don't do that. What we do is we actually modify this just slightly, and rather than plotting the vector, I'm going to plot the terminal point of the vector. In other words, 0, 2, and then 1, 3, and then the point 2, 4. And if I plot those, notice that that corresponds to this exact same line, 0, 2, 1, 3, and 2, 4. So when I plot a vector function, what I'm plotting in the xy plane, again, if it's a vector from R to R2, are the terminal points of the vectors. Okay? Let's take a look at another example. Let's say we wanted to plot the vector function r of t is equal to, let's say, 2 cosine of t, 2 sine of t, where the values of t range between 0 and pi. Okay. Well, let's plot a handful of points. In other words, let's start by looking at the input. Let's look at the output. And then we're going to look at the point. Well, let's pick some simple values for t, right? I'm not going to pick pi over 7 or the square root of 19. Let's pick something like t equals 0, and then t equals pi over 4, and then pi over 2, and then pi. We'll just pick 4 points. What is the output? Well, the output is going to be the vector that has the t value 0. So 2 cosine of 0, which would be 2, and then 2 sine of 0, which would be 0. But I'm not going to plot the vector to 0. I'm going to plot the terminal point of that vector. Again, let me mention the terminal point where I assume the vector is in standard position. Right? A vector that is here in the plane is equivalent to a vector that is here in the plane, even though the terminal points are different. But we're thinking of the vector that is in standard position. In other words, its initial point is at the origin. Okay. Pi over 4, well, 2 cosine pi over 4. 2 cosine of pi over 4 would be root 2 over 2, which is going to be root 2. And then 2 sine pi over 4. Sine pi over 4 is root 2 over 2. In other words, root 2, which means I'm going to plot the point. Root 2, comma, root 2. Pi over 2. 2 cosine of pi over 2. Cosine of pi over 2. Well, remember that pi over 2 is at the terminal point at the top of the circle with that angle, pi over 2. And the cosine value is the x value. So in other words, that would be 0. And the y value at the top of the circle is 1. So that would be 2 times 1, which is 2. And then if I go to pi, cosine of pi is negative 1. Therefore, I have negative 2, and the sine of pi is 0, so I have negative 2, comma 0. And again, that gives me my last 2 points of 0, 2, and then negative 2 and 0. I go ahead and plot those points. Plot those points over 2 up 0. That puts me here. Root 2 comma root 2 for plotting purposes. Think of that as 1.4. In other words, it's a little less than 1.5, so go over 1.5, back off a little bit, and then go up 1.5, back off a little bit, and then put a little point right there. And then for 0, 2, be over 0, up 2, and then back 2, up 0. The idea is that the graph, if I was to fill in, of course, more points, would look like this. It is the top half of a circle centered on the origin of radius 2. But notice for the initial plot, the initial point that I plotted, which is over 2 up 0, I didn't plot the vector that pretend this marker is a vector. Well, actually, go ahead and draw it in there. I did not plot that vector, and I did not plot this vector, and so on and so forth. What I did is I only plotted the terminal points of those vectors. Let's go ahead and get that out of there. Okay. And then once we know how to graph vector functions, we can start looking at things like, well, what's the derivative of a vector function? What does that represent? And we can do integrals and all sorts of calculus with vector functions. But again, this is just a quick video on showing you how to actually graph a vector function by hand. Thank you for watching, and please consider subscribing.